Hey you, do you like money? Yeah, you know, the things you buy stuff with. Money. Yeah, I'm pretty sure everyone knows what money is. You could say that everyone has an interest in money. Okay, this is my AlgeBruh project, and as you guys know, I will be talking about compound interest. What is compound interest, you ask?
An interest in compounds.
Just kidding, it's actually an interest that's paid over a period of time. It's like adding an interest to an interest over time. Two things to help you better understand this is monthly interest and quarterly interest. There's only one way to differentiate these two, and that is...
Sup dog, you find me here monthly. That means 12 times a year.
Well, sup dog, you'll find me here 4 times a year. That means every 3 months. To sum that whole thing up, monthly interest is paid once every month, meaning 12 times a year. On the other hand, quarterly interest is paid every 3 months, which means every quarter of a month, hence the name quarterly interest. The only difference between the two compound interests is the time at which they are paid. Monthly interest is paid 12 times a year, hence the word monthly interest. Quarterly interest is paid every quarter of a year, or 3 months. And in addition to that, monthly interest and quarterly interest have their own formulas. I will show this by the computer.
Now I'll be showing you the monthly interest and quarterly interest formulas. For monthly interest, you start out with A equals P parenthesis 1 plus R over N close parenthesis. Now it's going to be to the power of 12 since it's a monthly interest. T. Since it's a monthly interest, you can also say that N is 12. For quarterly interest, you're doing the same thing, except now you're plugging different numbers for N. A equals P parenthesis 1 plus R over N close parenthesis to the power of 4 T. N can also be 4 since we're talking about the quarterly interest. T stands for the amount of years. Everything inside the parentheses stands for the growth rate. P is the initial value, the money you start with, and A is your total.
So basically, to sum everything up, A equals the future value, P is the initial value, R is the annual rate, and N is the number of times interest is compounded. Like for monthly interest, it would be 12, since you're collecting it 12 times a year. For quarterly interest, it would be 4, since you're getting it 4 times a year. And T is years. I did some research with the rates and put the formulas into use in the real-life world. So it turns out that Bank of America has a 1% interest rate. I converted this to 0.01, which is its decimal form, not percent. I put that into our equation for the rate, which was R. Then I plugged in 35,000 for P. You end up with A equals 35,000, parentheses 1 plus 0.01 over 12 to the power of 12, close parentheses. When plugged into a calculator, you get this. Which is your value for 1 year with monthly interest. Now we're going to do the same thing for quarterly interest, except now we're plugging in different values for N. You're going to do A equals P parentheses 1 plus 0.01 over 4 to the power of 4 for 1 year. Then you're going to plug in values for P, which is $35,000, which is what we did before. And when plugged into a calculator, you get almost the same thing, only different cents. we said before that what was ever in the parentheses would be the growth rate. In that case, the growth rate, if the value was $35,000 for P, for the monthly cost, by the way, I put this into the calculator, would cost 1,00083. For the quarterly rate, it would cost 1.0025. I found this by solving for this area, which is the growth rate. So these two values are growth rates. So to sum it up, account A, if put $35,000 for P, would have $35,351.60 in it for a monthly interest. Account B, which has a quarterly interest, would have $35,351.31. And that's how much you save by only 1 year if you had $35,000 in your pocket. Good tip for the future, right? Hey, how about more years, like 10 years or 20 years? Here's another computer example.
Now I'm using a simple savings calculator that I found from Google. We're plugging in the initial value of $35,000. We're not adding anything, so $0. And our annual interest for quarterly was 1. As you can see, these are the values from year 1 to year 20. This is the year that we calculated before. Now, the monthly interest is a bit different. We're still having the same annual interest and initial amount though. The only difference really is the cents when it comes to the monthly interest. As you can see, our year 1 value, which we calculated, is still the same.
Using Desmos, I was able to find how the two graphs would visually look like. As you can see, I plugged in the two formulas that we found before, which was y equals 35,000, which is what the value we were using, parentheses 1 plus 0.01 over 4 to the power of 4. Same thing with the monthly interest. So the red is quarterly, the blue is monthly. From far, the graphs look the same. They both have a y-intercept of 35,000, which is about here. But the truth is they're not the same. When zoomed in on the graphs, you can see that they slowly begin to look more different and divide. The graphs are not the same. They have different values for n, making them different on the graph too. So yeah, this was a visual representation of the two formulas. To conclude, you can say that I learned a lot about compound interests. Though it may not be the most interesting, I think it may help you with life, choosing a bank and choosing a savings account. Before this project, I didn't even know what a compound interest was, so I guess I'm pretty glad that I looked that up and learned a lot about it due to this project. And since I learned something new that could help me in life, I would like to thank Mr. Kessler, the signer of this project, and the one who kind of helped me with it through all, the internet. I think the internet was really helpful all through this project, knowing that people in my family aren't really that good at math. Sorta.
So thank you, Google.
Yeah, so this has been my AlgeBruh project. Thanks for watching. Tiffany Magno is my name. Bye.